Yarns are the core components of all knitted and woven fabrics. Fabrics are specified as to the yarns and construction. The yarns that are used must have sufficient strength and elongation. These specifications include the size of the yarn strand, the type of yarn and its structure, strength, twist level if spun, and evenness among many aspects. Given the use of any fiber type, the properties of the yarn are affected by the manner in which these fibers are assembled. Yarn designations are standardized to make communication of yarn and fabric parameters easier and more precise. These yarn notations are used by textile mills, designers, product specifiers, apparel manufacturers, sourcing agents, and others to produce consistent and performing products. Covered in this CD are the yarn construction parameters of yarn structure, type, size, twist, and fiber strand configuration. Yarn structure relates to the orientation of the fibers that make up the yarn. For spun yarns, the orientation is related to the spinning system and whether the yarns are composed of a single strand of fibers or two strands of fiber twisted together. Yarn orientation is certainly related to the spinning system, and the different yarn spinning systems relate quite differently in production costs and performance. Therefore, the choice of spinning system is very important. The designation of the yarn type for a textile or apparel product is important for quality purposes. For example, an open-end spun yarn's overall performance and cost are better in the coarse to medium yarn count ranges. Yarn type refers to how the yarn is made and the components of the yarn. As mentioned in the fiber section of this CD, fibers are the building blocks of yarns, and the properties of the fibers have a big impact on the properties of the yarn. However, the orientation of the fibers in the yarn also impacts the performance of the yarn. In spun yarn manufacturing, ring spinning systems make the strongest, softest, and widest range of yarn counts. Open-end spinning makes yarn at a significantly faster rate than ring spinning, is more even, has lower skewness problems, but has lower strength and a narrower yarn count range. Open-end yarns are spun from very coarse to about a 40s singles yarn count. Ring-spun yarns can be spun from very coarse to over 100s singles yarn counts. Finally, air jet spinning makes yarns at the fastest rate with strength similar to open-end yarns, but from about a mid-20s count range to just above a 60s count range. Filament yarns can be manufactured in both untextured and textured bulks. The textured yarns are more bulky and can have stretch properties without the fiber being a stretch fiber. Untextured filament yarns are more compact and have better luster than their counterpart. For filament yarns, the orientation is related to whether the continuous filaments are flat or textured. Flat is the term for filaments that are parallel to one another and not textured, and therefore not as bulky. Yarn constructions are clearly defined in the ASTM test method D1244, Standard Practice for Designation of Yarn Construction. This document is designed to help users describe in consistent and accurate terms yarn characteristics and parameters. This standard covers all the basic single, plied, and cabled yarns for both spun and filament yarns. It's used by yarn mills and textile manufacturers to communicate the desired or specified fabric constructions. Yarn number refers to the nominal size of the strand. Sometimes yarn count is used instead of yarn number. There are various yarn numbering systems in use, and these can be classified as either a direct or indirect numbering system. Indirect systems refer to yarn numbers where as the number gets larger, the size of the yarn gets smaller. These systems are used for staple yarn spinning for both short and long fibers. Common indirect systems are English count, worsted count, woolen count, and other staple fibers. An example of the size relationship of the indirect system is that a 20s single yarn is larger than a 40s single yarn. For indirect systems, the indirect yarn number equals the number of yarn lengths of a specified weight of yarn. For example, the indirect count yarn number would be the same as the number of the specified yarn lengths that would weigh 1 pound. In the English or cotton count, the yarn number is the number of specified 840 yard lengths of yarn in 1 pound of that yarn. These 840 yard lengths of yarn are called a hank. Therefore, if the cotton or English count is a 40s, then there are 40 hanks of yarn per pound of yarn. This means that 840 yards multiplied by 40 hanks would be 33,600 yards of yarn. English or cotton count is abbreviated as NE. The worsted system for wool and other animal fibers specifies hanks of 560 yards. As a result, a 40s worsted yarn would have 40 hanks of 560 yards each for a total of 22,400 yards. It's easy to see that a 40s English count yarn is not the same physical size as a 40s worsted yarn. Worsted count is abbreviated as NW. There is an indirect numbering system that uses the metric system. This system is referred to as the metric count of a spun yarn. In this system, the size refers to the number of kilometers per 1 kilogram of yarn. Therefore, a 20s metric count would have 20 kilometers of yarn per kilogram of weight. Metric count is abbreviated as NM. Direct systems refer to yarn numbers where as the number gets larger, so does the size of the yarn. These systems are typically used for filament yarns, but not exclusively. Common direct systems are denier, tex, and decitex. An example of the size relationship of the direct system is a 100 denier yarn is larger than a 70 denier yarn. For direct systems, the direct yarn number equals the weight of the specified length of yarn. For example, the denier yarn number would be the same as the weight of 9,000 meters of yarn. If the denier is 100, then the yarn weighs 100 grams for every 9,000 meters of yarn. A 150 denier yarn length of 9,000 would weigh 150 grams. Therefore, it's easy to see that the larger the denier, the larger the yarn. A yarn numbered in the tex system would be the weight of 1,000 meters. Therefore, a 100 tex yarn would weigh 100 grams per 1,000 meters of yarn. Since the specified length of yarn for tex, 1,000, is smaller than that specified for denier, 9,000, a 100 tex would not be the same size as a 100 denier. It would be much larger. Decitex is a direct numbering system that uses 10,000 meters as the specified length. Since this length is similar to that of a denier, the resultant numbers would be similar in size. Another important factor in a filament yarn such as denier is that the yarn bundle is made of many filaments. If a 100 denier yarn has 40 filaments, then each filament would be composed of filaments of 2.5 denier in size. A 100 denier yarn with 100 filaments would have filaments of 1.0 denier in size. All staple spun yarns contain twist to hold the fibers together. Twist is described as the number of times the fiber bundle twists around its axis. The frictional forces created by the twist are the means by which all yarns are held together. Normally, the higher the turns per inch, the stronger the yarn, the firmer the hand, and the greater the potential for skew and torque. Different fabrics and end uses will require different levels of twist. Most single yarns will be produced with a Z-twist. That means that the helix angle is the Z direction. Sometimes S yarns will be produced for special technical reasons. An S-twist yarn's helix angle is in the S direction. S-twist is only available on ring spinning systems. Twist multiple, or TM, is a common way of designating and comparing how much twist a yarn contains. TM is a relationship between yarn number, or count, and the turns per inch in the yarn. Using number English or cotton count, that relationship is represented as follows. TPI equals TM times the square root of NE, where TM is twist multiple, TPI is turns per inch, and NE is number English, or cotton count. Twist level may also be expressed in other ways, such as turns per meter. In commerce, yarns are described by logically ordered symbols which describe its characteristics. For example, a designation of 24s singles NE cotton Z 16 TPI would mean a yarn size of 24, single strand, 100% cotton spun with 16 turns per inch of Z-twist. Other information might be the micronaire of the fiber. That designation might be read as 24s singles, NE cotton, 4.0 micronair, Z16 TPI. Another common designation would be whether the yarn was carded or combed. Carded yarns are normally identified as KP. However, this designation is not normally used, as the yarn is considered to be carded if not stated otherwise. Combed yarns are identified as CP. An example would be 24s singles NECP cotton Z16 TPI. Single yarns are the direct product of a spinning frame and are a single assembly of fibers. Two or more single yarns can be twisted together to create a plied yarn or cabled yarns. A typical plied yarn is formed by twisting two single yarns together in the opposite direction of their formation. For example, two 20s singles yarns of Z-twist are plied together with S-twist to form a 20s two-ply yarn. The first number in the designation is the size of the singles, and the second number indicates how many of these are twisted together. A 20s three-ply yarn would be three 20s singles yarns plied together. Yarns are plied primarily to increase strength and reduce torquing of the yarns in the fabric structure. It's important to know that the two yarns plied together do not have to be the same size or even fiber type or spinning system.